Okay, let's do page 2, okay? So, and flip the coin once. What is the theoretical probability that the coin will land on heads? Now remember, how many choices do you have when you flip a coin? Okay, so you only have 2 choices because it will either be heads or tails, okay? So what is a theoretically the coin will land on heads? So since you have 2 choices, heads or tails, the probability is 1/2, okay? 1/2 chance it's going to be heads, 1/2 chance it's going to be tails, okay? Now, and flip the coin twice, okay? Twice means 2 times. What is the theoretical probability that the coin will land on heads twice? For this, we need a probability tree. Now, in order to avoid confusion, because some of you might start with heads, no, you start with the coin. So this represents the coin, okay? Now the coin, when you flip it, can go either way. It can go heads or tails. So this is the first event, okay? You'll flip it, it will either be heads or tails. Now it says, and flip the coin 2 times. So the second time she flips, let's say the first time she got heads, okay? And then she's going to flip again. The coin still has 2 sides. So her next flip will either be heads or tails. And if she flipped the first time she got tails, and she's going to flip the second time, the coin still has 2 sides. So she can still either get heads or tails, okay? So now it's asking, what is the probability that the coin will land on heads twice? So we want head and head, okay? So what is the probability it will land on head? As we determined here, since there are 2 sides of a coin, it will land, there's a 1/2 probability it will land on head. So this is 1/2, okay? And 1/2 probability it will be on tails. So the second toss, the coin still has 2 sides. So what will be the probability that on the second toss it will still land on heads? It's the same, 1/2, okay? And if it will land tails, it's 1/2 for tails as well. And if you get tails first, okay, and you flip the coin again, there's still 1/2 chance it will be heads and 1/2 chance that it will be tails. It's always 1/2 because there are 2 sides to a coin, heads or tails. But in this question, we are interested in heads twice, okay? So this is what we're interested in. So we are interested in head and head. So the first probability is 1/2. The first row, there is a 1/2 probability that heads will come out. So on the second row, it's the same thing. There is a 1/2 probability or chance that heads will come out again. So what you're going to do, you are going to multiply the probability. So 1/2 times 1/2 equals 1/4. So there is a 1 in 4 chance that Anne will get heads when she flips the coin twice. Okay, so now let's go to the next example, the next question. It says she flipped a coin thrice. Now what does thrice mean? Thrice means 3 times, okay? So again, what is the theoretical probability that the coin will land on tails 3 times, okay? Tails 3 times. So let's make another probability tree, okay? So this time, start with the head, the coin, and the first try, it can either be heads or tails. So the second try, it can either be heads or tails, and heads or tails. The third try, it's the same thing. It can either be heads or tails, heads or tails, heads and tails, and the same thing here, heads or tails, okay? Now, which one are we interested in? We are interested in tails 3 times. So this is what we're interested in, tail, 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 okay? So again, what is the probability that the coin will land on tails? 1/2. And then 1/2. And the same 1/2. Why? Because the coin has two sides. So every time there's a half chance that tails or heads will come out. So let's do this. So tails, tails, tails. Okay, this is what we're interested in. And we said the probability that tails will come out the first toss is 1/2. The probability that tails will come out the second toss is still 1/2. And the probability that tails will come out the third toss is still 1/2. So all in all, it's 1 times 1 times 1 over 2 times 2 times 2. So the probability that tails will come out 3 times is 1/8. Okay? So what is the probability that the coin will land in this order? Head, head, tail. So let's use this one again so we don't need to draw another one. Okay, I'll use green for this one. Okay, so we are interested in head, head, tail. Okay, so this is what we're interested in, head, head, tail. So let me just put it down here. Head, head, tail. Now, what is the probability that head will come out the first toss? You're right, 1/2. What is the probability that head will come out the second toss? Still 1/2. And what's the probability that tail will come out the third toss? It's still 1/2. So 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. So the probability that the coin will land in this order, head, head, tail, is still 1/8. Okay? And flip the coin 3 times, and the coin landed on tail all 3 times. What is the theoretical probability that the coin will land on tail 3 times? Okay? So that's the answer. Okay? Flip the coin 3 times, and it landed tail, tail, tail. Okay, so now let's go to page 3. What is the experimental probability that the coin will land on tails? Well, at this point, we can skip this because we did not exactly flip the coins, because experimental is you actually go and flip the coins and count. Okay, so let's go to the next question. Okay. Complete the frequency table. So this is a frequency table. Okay, you have tally marks and you have frequency. Frequency is merely counting the tally marks. Please count properly. Okay, so this is 5, 10, and 13. So, and this is 5, 10, 15, and 16. This is 8. And this is 13. Okay. So let's see. Let's look for the cumulative frequency. Cumulative frequency is just counting the total. So the first is 13. 13 plus 16 is 29. 29 times 8 is 37. 37 plus 13 is 50. So how many times did they flip the bottle? They flipped the bottle 50 times. Okay. What is the experimental probability of stand, stand, stand? Okay, experimental now is based on the actual table, okay, on the actual results of Roy, Sam, and Tom actually flipping the bottle, okay, not because of the probability tree. So stand, stand, stand. This is what we're interested in, and how many times? 13. So the experimental probability is 13/50. What is the theoretical probability of stand, stand, stand? So now we'll use the probability tree. So let me draw a bottle here. So whenever, okay, if you were into flipping the bottle last year, the bottle will either stand or it will fall. Okay, let's draw a dead bottle. There you go, stand or fall. So the first flip, it's either going to stand or fall, okay? And standing doesn't, it doesn't matter if it stands on the top or the base, okay? So the second throw, because we're doing 3 throws, so this is the first throw. The second throw, it's the same choices. It will either stand or fall. Okay, stand or fall. And then the third throw, again, it will stand or fall, stand or fall, stand or fall, stand or fall. Okay, now, so what is the theoretical probability of stand, stand, stand? So where will we find stand, stand, stand? Here it is, stand, stand, stand. Okay, stand, stand, stand. Now what is the theoretical probability that you will get stand? 1/2, because there are only two choices. It will either stand or fall. So the same here, 1/2 and 1/2. So 1/2 times 1/2 times 1/2 equals 1/8. So the theoretical probability of stand, stand, stand is 1/8. Okay, so let's go to the next question. There were 18 marbles in the bag. Okay, 7 were black, 2 were white, and the rest were blue. So we have black, and we had 7 of those. White, there were 2, and blue. Now, we don't know how many blue are, but we do know there's a total of 18 marbles. So what do? 9, 18 minus 9 is 9. So there are 9 blue marbles. So the first question, what is the probability the black marble will be pulled out of the bag? How many blacks are there? 7. So it will be 7 over 18. And that's lowest terms already. What's the probability that white will be pulled out? 2 over 18 or 1/9, because you have to simplify, okay? Now let's go to the next page. What is the probability that the blue marble will not be pulled out of the bag? So remember, we have, let's just do a quick going back to the other page, okay? 7 black, 2 white, and 9 blue. So what's the probability that blue will not be pulled out? So we know that there are 18 marbles total, okay? 9 are blue. So if we're not pulling out blue and there's 18, so we know 9 are not blue. Okay, so the probability we're not pulling blue is 9 over 18 or 1/2. Okay, so let's do the next one. Look at the spinner on the left. What is the theoretical probability that the arrow will point out to the red section? Okay, so how many red sections? 1, 2, 3, 4. How many sections does the spinner have in all? Okay, 5, 6, 7, 8. So the theoretical probability that the arrow will point to red is 4, because there are 4 red sections, over 8, which is the total, or 1/2. Okay, what is the theoretical probability that the arrow will point to yellow? Yellow, how many yellows? There's only 1. So 1 over 8. What is the theoretical probability the arrow will not point to the red section? Okay, so if it's not red, that would either be blue or yellow. So there's 1, 2, 3, 4. 4 over 8 or 1/2. The arrow was spun 100 times. What is the probability it will land on red? Okay, so let's look at this one. 100 times. And what is the theoretical probability it will land on red? 1/2. So times 1 over 2 equals 100 over 2 equals 50. So the probability it will land on red would be 50 times, because the theoretical probability it will land on red is 1/2, and 1/2 of 100 is 50. Okay, the arrow was spun 100 times. It landed on red 60 times, blue 32 times, and yellow 8 times. What is the probability that it will land on yellow on the next spin? Okay, so this one, it says on the next spin. Okay, so you can look at it this way. Since it was not spun yet, then we're looking at theoretical probability. And that the theoretical probability it will land on yellow on the next spin is 1 over 8. Okay, this is the theoretical probability. But if you want to base it on the results of the experimental probability, okay, 100 times it landed on on yellow 8 times. So that is 8 over 100. So what is that? Divided by 4, that will be 2 over 25. So if we are basing it on the experimental probability, then there will be a 2 out of 25 chance that it will land on yellow on the next spin based on this one. But personally, I would say 1/8 because it says the next spin. So I am assuming you have not yet spun the arrow, and therefore it's still a theory. 1/8. Okay. What is the probability the arrow will land on red instead? So if we're talking about theoretical probability, it would be 1/2 because the next spin, it's not yet the arrow was not yet spun. But if we were to base it here, that would be 60 over 100 or 6 over 10 or 3/5. Okay, 3 out of 5. Okay. So this one, flip a coin 50 times. Okay, this one you needed to do by yourself. So you can do it at home. Flip a coin 50 times and tally it and do a frequency table. Okay, but for now, let's go to the next page. Okay, what is the theoretical probability of the coin landing on heads? And as we talked about a while ago, there are two sides, heads or tails. So that would be 1/2, 1/2. Okay, now based on the results of your activity, what is the experimental probability? You need to do that by yourself, okay, and you need to do this by yourself. Now let's talk about dice. Okay, die is the singular of dice. Dice is plural. Now what is it? It's a 6-sided cube that has, okay, the numbers 1 to 6 on all its sides. Okay, so draw probability 3. It's rolled twice. So we're starting with a die. Let's draw a cube there. Okay, so we have 6, okay, chances. So it will either come land on 1, 2, 3, 4, 5, 6. Okay, so each probability is what? Okay, you guessed it. So 1/6. So each has a 1/6 chance of appearing. Why? Because there are 6 sides to the dice and each side has a 1 in 6 chance. Okay, now it's saying what is the theoretical probability that the die will land on 6 twice in a row? Okay, so basically, if you had the time, if on the first throw, this is the first throw, you throw 1, the second throw, you still have a 1 in 6 chance. 2, 3, 4, 5, 6. Okay? So the next throw is still 1/6 that you might get a 1, 1/6 that you might get a 2, and so on. But what are we interested in? We're interested in 6 the first time and 6 the second time. Okay, so getting 6 the first time is 1/6. And if we throw the die again, what is the probability that we will get 6? It's the same, 1/6, because there are 6 choices. So this is the first event, the second one. So how do we get the probability? Same as before, we multiply. 1/36. So the probability of getting 6 and another 6 twice in a row is 1/36. Okay? And let's go to the last one. What is the probability of Mrs. Nass not giving a mad minute? Not giving mad minutes is 1/20. The probability of everyone in 8A and 8B of bringing a ruler during a linear equation assessment is 0.07. Which event is more likely to happen? So again, you cannot compare if they are not in the same format. Either make this into a decimal or make this into a fraction, okay? So let's make this into a fraction. This would be 7 over 100. But we cannot compare because they have different denominators, so we need to make them into like fractions. So I will multiply the numerator and denominator by 5, which will give me 5 over 100. Okay? And as you can see, that it is more likely that 8A and 8B will bring the rulers to a linear equation assessment than Mrs. Nass not giving mad minutes, okay? Because 7 over 100 is greater than 5 over 100. Okay, so let's do the last page, and the last page is geometry revision. Yay! So let me just make this a little bit bigger, okay, so that it's easy to look at. Oops, okay. So now let's look at this one. We're looking for angle 1, 2, 3, 4, and 5. Okay, so if you look at this, which one would be the easiest one to solve first? Okay, I would do this. This number 5 for me is the easiest. Why? Because I can already calculate this one. This is going to be 180 minus 140 because there are supplementary angles. And supplementary angles total 180. So this would be 40. Now, I can now calculate for this one because angle 5 plus 72, angle 5 plus 72 plus 40 should equal 180 because the sum of the internal angles of a triangle equals 180. Okay, so this would be angle 5 plus 112 equals 180 minus 112 minus 112. Angle 5 is equal to 68. Okay, so this is 68 degrees. Okay, so now angle 4 is easy as well. So angle 5 is 68 degrees. And as we mentioned, it's internal angles of triangle equals 180. Angle 4 would be 108 degrees. Why? Because they are supplementary angles. Okay, now since we know this is 108, this would be 72, either because they are vertical angles or these two are supplementary. Now I can calculate this one. This would be 45. Why? Because these two are supplementary angles and they total 180. So now I can calculate for angle 3. Angle 3 plus 45 plus 72 equals 180. Why? Because sum of internal angles is 180. Okay, so angle 3 plus 117 equals 180 minus 117 minus 117. Angle 3 is equal to 63 degrees. Okay, so angle 3 is equal to 63 degrees because internal angle of triangle equals 180. Okay, so now since I know this is 45, I can say that this is 45 as well. Okay, 45 degrees because they are vertical angles. And vertical angles are equal. Or you can say It's 45 because these two are supplementary angles and they total 180, okay? So this one you can solve two ways. Number one, you can use the external angle rule, or you can use the internal angles of a triangle, okay? So let's use another one, the external angle. So it says the external angle rule is the external angle is equal to the sum of the internal angles. So angle 1 is equal to 60 plus 45. Angle 1 equals 105 degrees, okay? 105 degrees because of external angle rule. Okay? Now let's prove that it's correct. Let's use this one. Oh, never mind, because if I do this, okay, 60 plus 45, 60 plus 45 equals 105, and then 180 minus 105 is 75. So this would be 75 because internal angles of a triangle equals 180. And then let's solve this by supplementary. 180 minus 75 equals 105. So this still ends up to be 105, proving that the external angle rule is correct. Okay? So, hope this helps you. Okay? Remember, revise, revise, revise. Practice makes perfect. Okay, bye-bye.